Hello, welcome back. And now we'll be finally programming something into our finished computer, or at least finished for now. And the program I have chosen to try is this multiply program using the shift and add method. This is not the whole multiplication tables calculator, because this one is much longer and it's a bit annoying to program using the dip switches. So we'll just try the one-time multiply by the shift and add method. And the way this program works is it starts by resetting the register A, then storing a 4 on register D. That's the maximum multiplier bits that this program can handle because of this shift and add method. Then storing our RB, our multiplicand, and on the RC, our multiplier. Let's try here something like 13 times 15, that's okay. And then we'll rotate left RC 7 times in a row, which actually represents a single shift right. And then if we have a negative, that means if the last bit is set, if the most significant bit is set, it doesn't mean actually a negative number for this program here, but then if we have that situation, we'll jump for the add subroutine and we will make one add. We'll add RA to RB. Our RA starts at 0, then we add RB, and then return to this point of the program. If we don't have a 1 set, we'll just come to this part of the program anyway, and then we will shift RB left, which is our multiplicand, decrease RD, which is our maximum multiplier bits, and the number of times maximum we will repeat this loop. And then if we finally had a 0 on this RD, we would finish the program, and if not, we'll just jump to the beginning of the loop and then shift RC right one more time. That means rotate it left 7 times and repeat this again. So let's go for the programming part on the computer. And the way it works here is we have to stop the clock. It's already stopped. Then we put the computer into programming mode, and then we start entering the data that we need. This bottom dip switch here is for the address, and the top one for the data. So for address 000, we have their data 1111 000, and then we click right, then we can check, yep, that's correct, then address number 1, and so forth. Great, I think that was it. We can now try to run the program and see if it works. Get out of programming mode, resetting, then let's let the clock run. There it is, 195. So it seems that I've entered all the bits of the program correctly, and we can try some other multiplications. I don't know. Let's try 3 times 15. Let's just change this address 4 of the program. Let's go to address 4. Address 4 is now 3. It was before. Let's see what's there. 13, and now we'll have 3 stored. Okay. Now let's reset the program, let it run. That's it. 3 times 15 is 45, or rather 15 times 3. And the way this program works is, as I said, by the shift and add method. If we want, we can step through the program manually by just stopping the clock and then manually clicking the advanced button here, the manual clock. Then we see what will happen. So at first we should clear our A, and then write a 4 to our D, then write a 3 to our B, and then write a 15 to our C, and then we'll start to rotate RC left, so it will correspond to a right shift. We'll do that 7 times. A right shift should actually stop here and have a 0 here, but that's the way this computer will do the right shift. And we'll also detect if we had a 1 that was shifted out, because it's actually here, and we have our negative flag on. And that we will use to go for the add part of the program. We'll add our A to our B, so we should have a 3 here added. Yes. Then we'll come back to the return instruction where we'll shift our B left 1 time. So now we had a 3, now we have a 6, and we will then go to the beginning of the program again, to the beginning of the loop, where we'll then take and rotate again this 7 times to the left. And again we have a 1 is a 15, we will also have a 1, we'll go to the for the add, we will add 3 to 6, we'll have a 9, that's it. And we'll shift this to the left, where we had the 6, and now we have a 12, we'll add a 12 to 9. Because again, we'll have a flag, our negative flag on this bit. (21) as expected, 12 plus 9. Then we can continue. We'll shift this to the left one more time. And now we'll have an 8 plus 16, that's 24, so we'll have 21 plus 24, which is the 45 we're waiting for. And sure enough, there's the 45. So that's it for this video, I guess. The computer is working, and there's a setback that we can already tell is that the programming through the dip switches takes a very, very long time, and this is something I wish to address on next videos, is to make some kind of a loader to automatically load whatever programs we already have written directly to run, and I will use a microcontroller for that. See you then!